Hey everybody, it's Cal from Wise Guys Tutoring. Today we're going to be doing our video on addition and subtraction of fractions. So it's a little bit more challenging than multiplying and dividing, but with a little bit of practice we'll get there. So without further ado, let's do some addition and subtraction. So let's start with addition, and then we'll transfer over to subtraction. So there's two main things that you need to know, okay? The two main things are this. You must have the same denominator, okay? That's the name of the game. You cannot add them if they have different denominators. And the second thing is you only add or subtract the numerators. You leave that denominator alone, okay? So let's use an example right away. Let's say you have 1/4 plus 1/2. Okay, right away you can see that they have different denominators, right? You have a 2 and you have a 4, and therefore you can't just simply add them, okay? Right off the bat, let me tell you guys, this is not 2/6, okay? You can't just go around adding numerators and denominators. It doesn't work like that. Rather, what you have to do, I'll rewrite it. I'm going to leave that example up because, I just want to make sure you completely understand that that is not allowed. It's not permitted, not correct. So what you need to do, first of all, we can recognize that the 2 is a factor of 4, isn't it? So what we're going to try to do is make an equivalent fraction with my 1/2. So what I'll do is I'll multiply the bottom and the top by 2. If you remember, that's how we were doing the equivalent fractions. Now what this gives me is a new set of fractions, which is 1/4 plus 2/4. Now remember, this one here is just the equivalent of the 1/2 that we had earlier. I just rewrote it so that our denominators are the same. Why I did that is because now that the denominators are the same, I can simply add my numerators, 3, and keep my denominator. Again, denominator stays the same throughout. You don't need to add it or subtract it or whatever. You only work on the numerators. Okay, now I'll give you another example just to make sure this is clear. So let's say you have, for example, 1/6 plus 2/3. Okay, again, we can recognize that this 3 is a factor of 6, right? So what I'll do is try to make an equivalent fraction where my denominator of that second fraction is 6. And by multiplying both by 2, I get 1/6 plus 4/6. So this gives me 5. I add up the numerators, and I got to keep my denominator. Remember, denominator always stays the same. So that would be my answer. So whenever you recognize that one of them is a factor of the other, I'm talking about the denominators, of course. When the denominator is a factor of the other, try to make an equivalent fraction in which the denominators will be equal. And in that way, you can simply add the numerators and keep that denominator the same. So if you have 1/2 plus 1/3. Now the 2 and the 3, they do not have, they're not factors of each other or anything. So we're going to have to multiply out both of these fractions. Now what you do is you multiply him by the denominator of the other, and we're going to multiply them by the denominator of the other. And the reason that this works is, as you'll see, we're going to get them both under the same denominator. So we'll multiply the top and bottom by 3 here, and we'll multiply the top and bottom by 2 on this side. Now, what does that give me? It gives me 3/6, right? That's the orange one, plus 2/6, being the pink one. And now look, now I have the same denominator. And that means that I can simply add up my numerators and put them over the denominator. Okay, well, that was a coincidence. I didn't mean to get the same answer. I hope to give you, more original examples, but that's basically it. So we can try something else. We can try something like 2/5 plus 4/7, right? So they are not factors of each other or anything. So you're gonna have to multiply this one on the left by 7/7, and you multiply the one on the right by 5/5. And we're allowed to do that because all we're doing is creating these That would give me 14 over 35. We're creating these equivalent fractions, right? We're not changing anything at all. We're just changing the shape of it, if you like to think of it that way. So this will give me 34 over 35. What I'm talking about are these, in case you haven't noticed, is that this one is simply 2 over 5, just written in an equivalent shape, right? And same goes for the 20 over 35. This one is the same as 4/7. It's just written in a different shape. And the reason I wanted it a different shape is that I want the denominators to be the same. Otherwise, I'm not allowed to add them like the way I'm doing right now. So let's try some more examples. How about 2 over 9 plus 2 over 3? And of course, feel free to pause the video if you'd like to try it for yourself now. So noticing that 3 is a factor of 9, what I'm going to do now is multiply out this one by 3 over 3. So this is going to give me 2 over 9 plus 6 over 9. So now that I have them under the same denominator, that's simply going to be 2 plus 6, 8 over 9. And that would be the answer. There is kind of a special case. Let's see if you guys can figure it out. Let's say we have an integer, something like 2 plus 1/5. So we know that when I have an integer, it's basically over 1, right? And to get these under the same denominator, I'm going to have to multiply this one by 5 over 5. And that's going to give me 10 over 5 plus 1 over 5. And now I can simply add the 10 and the 1. And I keep my denominator, of course. And there's your 5. Okay, so whenever you have that integer, remember, denominator is 1. And then you just treat it like any other fraction. Okay, you can multiply top and bottom by the denominator or the other in order to get it, under the same 5. And then you can add them up very easily. Okay, now let's do a little bit of subtraction. We didn't talk about subtraction specifically, but it's exactly the same. So for subtraction, you do the same thing, except you're going to have to subtract the numerators, okay? The denominator stays the same as before. So again, let's do another example. Let's say 1/2 minus 1/3. Again, this is a case where they are not factors of each other. You're just going to have to multiply them top and bottom by the denominator of the other, and that'll give you both of them over 6. And then we can work with that. So it's 3 over 6 minus 2 over 6. And you just subtract 3 minus 2. That gives me 1 over 6. That's the answer. So as you can see, subtraction is exactly the same as addition. Only obviously you subtract. Again, we can try something else. Something like 3 minus 1/4. Okay. When you have an integer, that means it's basically 3 over 1. And that means I'm going to have to multiply this guy out by 4 over 4 to get my equivalent fraction with a denominator of 4. That gives me 12 over 4 minus 1 over 4. 12 minus 1 is 11, keeping my denominator 11 over 4. Sometimes you might get something, for example, like 3 over 8 plus 7 over 12. Okay. Now you might figure, hey, these are not a factor. The 8's not a factor of the 12, and you might go multiplying them by 12 over 12 and 8 over 8, right? And that would not be wrong. You would get the correct answer. But the problem is that there's a simpler way, and you guys know by now, I always like to be more efficient. So what you'd have to do is find the lowest common denominator. The way you do that is by multiplying him out to 24. 3 times 8 is 24. And you multiply this guy out by 2 over 2 to also get a denominator of 24. Now this is a lot simpler, right? You get 9 over 24 plus 14 over 24. This is a lot more manageable, 23 over 24. Whereas in this case, you'd get 36 over 96 plus 56 over 96. And now this one gives you 92 over 96, which you can divide by 4 on top and bottom to simplify. And that still gives you 23 over 24. But like I said, extra steps, no need. If you recognize that there's a lower common multiple than multiplying them by each other, then you should definitely go for that. So I recognize that 8 and 12 have a lowest common multiple of 24. And how do I get to 24? How do I get the 8 to a 24? I multiply by 3. And how do I get the 12 to 24? I got to multiply by 2. The bottom line is all you're trying to do is just get your denominators to be the same one way or another. There is one more thing I'm going to leave you with here, and it's called the butterfly trick. So it's like a shortcut. I'm not a big fan, but to be honest, it works. So I'm just going to show it to you. So the butterfly trick goes like this. Let's say you have 2 over 5 plus, 4 over 7. Okay? So what you do first is you take these two guys and you multiply them. And that gives you, put a little antenna, that gives you 20, right? And then you take these guys here and you multiply them, and that gives you 14. And down here you multiply the denominators, and that gives you 35. So the answer ends up being 14 plus 20 over 35. And that's correct. It's not wrong. Okay, it's essentially the same thing. If you notice, you're multiplying the 7 by 5 and the 4 by 5, and you're multiplying the 2 by 7 and the 5 by 7. So you end up getting the same thing. But some students prefer it. So there you go. Why not? Who am I to say what way to use? I just like to show you the where it comes from, or the real way, quote unquote. But if you like this trick, then by all means go for it. So let's try a subtraction just for fun. So we'll do the same thing. You multiply these two guys. So this gives you 24. And then you multiply these two guys. You put it under that antenna. I like to draw. There you go, 5. And the denominator is going to be 5 times 6 is 30. So you get 24. This time, remember, we're subtracting. So 24 minus 5 over 30. That's 19 over 30, which is correct. So that's how you do the butterfly. If you prefer that way, then by all means go for it. I'll give you a small recap. Basically, what you want is the denominator to be the same. And the way that you do that is by finding an equivalent fractions. Either one or both of them must change. But you change at least one of them to get the same denominator as the other. Then you can just add and subtract the numerators very easily while keeping the same denominator. Sometimes you may want to, multiply them by each other, but if you can recognize the lowest common multiple, that would be better, like I did with the 8s and 12s and 24s. Otherwise, even if you don't recognize that you want to multiply them by the denominator of the other fraction, go right ahead. Just be careful when you simplify. So that's it for addition and subtraction of fractions. I hope it was clear, and you got that butterfly trick also if you want to use. And we'll see you in the next video. Please like, subscribe. If you have any comments, suggestions, just write to me below, and I'll catch you guys in the next one. Thank you.